Hello fellow programmers, in this tutorial we are going to create a bullet penetration system with real physics objects as bullets. The only things you need for this to work is a proper player controller and a gun that shoots bullets, and these bullets need to have their own script. That is everything you need. So let's hop right into it. Let's start with a demonstration of the system. Here we have a wall where the bullet shouldn't go through because it is too big. And as you can see, the bullet doesn't go through. Here we have the second wall, a not so thick wall, and the bullet should go through. And yes, it does. And here we have 4 pieces of a wall, and here the bullet should also go through because the 4 walls are very thin. Okay, it went through. So let's open up our bullet script. In my bullet script, I've currently the logic to let the bullet explode on an impact, and we are gonna expand it now with bullet penetration. So let's start by creating 2 variables. A SerializeField private float penetrationAmount and a private vector-free lastVelocity. In the update function, we keep track of the lastVelocity by applying the rigidBody.velocity. RB is my rigid body. My main code is in the OnCollisionEnter function. You need to have that one as well. So I have here some basic logic for taking damage on the enemies and for exploding the bullet. So after the take damage function, we are gonna build our code. Why after the take damage function? If we want to penetrate an enemy, the enemy should still take damage because the bullet goes through the enemy and with that hits the enemy. So let's create 3 more variables: a vector-free penetration point, a vector-free impact point. We can actually set that to collision.GetContact 0 because 0 is the first contact in here. .point, which returns a vector-free. And you don't need to do this, but this is great for gizmos if you want to have some, a vector-free endpoint. So let's set up our ray. We call it penetrationAray, and it is equal to a new ray. And as our origin, we have collision.GetContact 0, again the first contact, .point plus transform.forward times penetrationAmount. This just puts the origin of the ray far behind the object we want to penetrate. And as the second argument, we want to get the negative direction of our bullet. We can do this by saying negative transform.forward. What this will mean, it will shoot a ray in the direction of our bullet. So let's create another variable for our RaycastHit and let's just call it penHit. Let's create an if statement so that we can check if we hit the object with a raycast. And in here we say collision.collider.Raycast. What this will do, the raycast will only check for the collision.collider. If there's another object in the way, it will ignore it. And this is very important. In the arguments for the raycast, we just pass in our penRay, out penHit, so it will store all the raycast information in that RaycastHit called penHit variable, and for our max distance we just pass in penetrationAmount. So if we hit our object, which we should, the first thing that we're gonna do is set the penetrationPoint, which variable we set up earlier, to the penHit.point. So this just means the point of impact of the raycast. If you want to work later on with gizmos, we need to set the endpoint equal to the transform.position plus transform.forward times 1000. The next thing is a float distance of penetration. So how thick the object we want to penetrate is, so the length of the penetration, and this is equal to vector3.distance, and the arguments are impactPoint and penetrationPoint. So this just gets the distance between impactPoint and penetrationPoint. The next thing we need is a float speed change. We can apply this later to our bullet's velocity to slow it down based on how much our bullets slow down. And this is a bit more complicated, but if you look at it closer, it will make sense. 1f minus bracket distance of penetration divided by penetration amount and close the bracket. This will clamp the value distance of penetration between 0 and 1, and then we just subtract it off of 1f. Next thing we want to do is subtract the distance of penetration from the penetration amount and pass that to the penetration amount. We can just do that by using the minus equal operator. This is useful if the bullet penetrates multiple objects on its way, so it shouldn't penetrate two objects that are very big, only the first one. But that's all nice, but how do we get the bullet to the other side of the object? Sadly, there is no such way to disable the collider only for the bullet. At least I didn't find one. If you got one, then please tell me in the comments. My way of doing this is just by teleporting the bullet to a new position. So we set the transform.position, so our bullet's position, equal to penetration_point, so the point of penetration, plus transform.forward times a small number. This small number should be greater than the half of your bullet. I just set it to 0.25f. So, but when I tried the system out, there was one bug. When bullet got teleported to the other side, it sometimes just flew in a completely different direction. If you want that, that's okay. In some games that's actually a feature, but I didn't quite like it. So we just set the rb.velocity equal to the lastVelocity. What this will do, will just set the velocity we got in update to our rb.velocity and multiply the lastVelocity by the speed change to apply the speed change. And lastly, what I wanted to do, this is of course completely personal preference, but if you want to do it as well, I like to have some debug.logs to see what actually is going on. So I'll just put into the debug.log penetrated object and put in there the name of the object by using collision.GetContact.name, and the penetration amount consumed is the distance of penetration, and the speed change is the speed change. And now I forgot, and this took me half an hour to find out, but you need to put return at the end. What this will do, it will close the function on OnCollisionEnter, because in my case it just called the explode function and the bullet exploded, so there was no penetration. So make sure to put the return statement there, or use some other logic. So let's try the system now. It shouldn't go through that wall here. Yes, it doesn't. Let's try next wall. And it does go through. And if you look very closely, I will put it in slow motion, you will see that the bullet slows down by a lot. Okay? And last test, here 4 walls, very thin, behind each other. And yes, it works. And as you have seen here at the end, the bullet dropped slowly because it went so slow because of the 4 walls and the enemy, and it successfully damaged the enemy. So that's the penetration system with real objects as bullets. If you have any questions, write them down into the description. If you have any ideas for future videos, please tell me in the comments. And if this video helped you, or you actually use this system in your game, please like the video, it would help me a lot. Thank you very much for watching, and we see us in the next tutorial or devlog.